So far we've spent a couple of lessons looking at different ways that we can count ordered selections, where the order actually mattered. Today we're turning our attention to counting unordered selections, which are also called combinations. Now, we've already got a couple of methods that we could use to count these, but we're going to look at a new method that will make our life a whole lot easier. Now, the easiest way to probably tackle this is just to jump straight into an example. How many ways can you choose 2 items from 5? All right, so let's say we have 5 shirts and we want to choose 2 shirts, or perhaps we have 5 letters and we want to choose 2 letters. Now, so far, all we've considered is, well, which one are we choosing first and which one are we choosing second? In this case, we're saying it doesn't really matter. I just want those 2 things. How many ways can it happen? So one thing we could do is we could actually just count the ordered selections. We also call those permutations. And then we could divide that by the number of selections that were actually identical and that we'd counted more than once. So if you consider that we've got 5 items, let's call them A, B, C, D, and E. And we choose 2. Let's say we choose A and then B. But that's the same as choosing B and then A, isn't it? So can you see how our ordered selections are going to give us twice as many as we need? Now, the way to get our ordered selections, 3 methods here that I've put into 3 different boxes, all of them are perfectly fine ways to do it, and we've seen that there's multiple ways that we can calculate our permutations. One way would be to say, well, there's 5 ways I can choose the first item and 4 ways I can choose the second item, but half of those are the same. I need to divide by 2 factorial because, for example, if I've chosen A and then B, or B and then A, that's the same as choosing an A and a B. And if I don't care about the order, I've obviously overcounted by a factor of 2 factorial. So this will give me 10. Similarly, you could work out the permutations by using the 5p2 button on your calculator and then realizing again that you'd overcounted, so you need to divide by 2 factorial. Or you could use the formula for 5p2, which is 5 factorial over 3 factorial, and we get that 3 from doing 5 minus 2. But similarly, you'd need to divide by 2 factorial, and here I've written it as a division just so I don't have fractions within fractions. And all of those will give you the same answer, which is 10. Now, let's just go old school. If you were really stuck with a question like this, you could use letters or any other symbols or numbers or whatever you wanted to visualize the 5 items, and then you could just write out all of the combinations that you can think of. Now, this is not a bad thing to come back to. Whenever we're tackling something new, it's always good to just think, well, what would I do if I didn't learn any of this maths and I just had to solve this problem? I could write them out. There's not going to be too many, there's only 10 of them. Now, if A is definitely one of the ones you've chosen, the A could go with B, C, D, or E. Write them out using some sort of system so that you can check that you've got them all. Now, when we go to write out ones that don't have A in them, it makes sense to say, well, what if it had to have B? Now, there's no point putting BA because we've already got AB and that's the same. And there's no point having BB because we can see that we're choosing 2 items. And so we want 2 things. We can't get the B twice. So we need to start with BC, and then we have BD and BE, and you can see a pattern here. We're going to have a list of 4 items, 3 items, 2, and then 1. So this 10 that we've come up with here, you can see it here quite clearly. It's really 4 plus 3 plus 2 plus 1 to get our 10. Now, the last way that I'm going to suggest, and this is our new way, the one that we're learning today, is we can use this formula here, NCR. Now, we've already seen NPR. The C stands for combination because that's a term that means an unordered selection. We can write that in up here on our heading if you like. And conveniently enough, the C also sort of stands for choose. So you can think of it as N choose R. How many ways can I choose R things out of N things? And that can help you remember. So we'll put a little choose in there, because it's a good way of helping you remember how to use it. Now, this formula here, we can actually sort of prove looking at our own reasoning back further. So here, when we divided by 2 factorial, another way that we could have written that is we could have multiplied by the reciprocal. So let's write it around that way. And we can see that we would have had this. And then, of course, we could smush that into one big fraction, and we could have written it this way. Now, that's exactly what we have here, and We'd sort of referred to this a little bit in our last lesson when we saw this come up. When there's only two items that you're choosing, you get this situation where the two factorials on the bottom, the numbers add together to make the one on the top. Now this NCR notation can also be written like this, with the N and the R vertically and brackets around it. You can see those interchangeably. We call it N choose R, no matter which way it's written. Now the C doesn't strictly stand for choose, it stands for combination, but it works well enough to think of it as choosing R things from N things. So it's the number of ways R items can be chosen from N items when order is not important. Now if you're working with the same numbers, let's say we've got 5P2 and 5C2, and you're comparing the two, well, there'll always be more permutations than there are combinations when the digits are otherwise the same. And that's because permutations are taking order into account. So something being first and something else being second, that's the same two items. And when we're just looking at the combination, we don't care what's first or second, we just care what the items actually are. So the formula for N choose R is N factorial over R factorial times N minus R factorial. Now you can calculate it by using this formula and actually working with factorials and unrolling them or simplifying them or just putting them into your calculator, or you can actually use the N choose R button on your calculator. So a little bit of practice with both. If we had this one, 6 choose 2, we could literally type 6. Now the N choose R button is right beside the NPR button. It's the divided by. So it's the yellow function. So we type in our 6 and then we hit shift divide by and it puts a little C there. And then we put the 2 and then hit equals and it should give you 15. And just to check if we can do it the other way, it would be the same thing as saying 6 factorial over 4 factorial times 2 factorial, which of course you can type into your calculator, or you could reason that the top is going to be 6 times 5 times 4 factorial. The 4 factorials will cancel. So you'll effectively have 6 times 5 on the top and 2 on the bottom. And of course 30 divided by 2 is 15. So I can see that that would work out. But there's a bunch of ways that you can do the same thing. Practicing again, 10 choose 3, type in 10, shift divide by, then the 3, and we should get 120. Or you could do it longhand. Now, you might think, well, why would I ever do longhand if I can just always use the N choose R button? Well, perhaps it's something that you can't put in and you have to tidy it up as best you can. So in this case, we've got X choose 4. We would have to write that it's X factorial over 4 factorial, X minus 4 factorial. Now, 4 factorial can be simplified. That's 24. So if you wanted to, instead of putting the factorial in there, you could actually just write a 24. And now you've got an expression showing this in a little more detail. Now, it's important to be able to spot complements when they pop up, and they actually pop up surprisingly often. So if you are looking at the number of ways, for example, that you can choose 2 items from 6, don't forget that when you've chosen 2 things out of 6, you've effectively not chosen 4 things. So it makes sense really just logically that choosing 2 from 6 is the same as not choosing 4. But if we look at the formula and how it's applied, it makes even more sense, because 6 choose 2 is 6 factorial over 2 factorial times 4 factorial, and 6 choose 4 is the same thing. We've just got the items around the other way on the denominator. So you can see that it's going to be exactly the same. So we can simplify that then into a rule. N choose R is exactly the same as N choose N minus R. And sometimes this will lead to much simpler calculations. Now let's see how this all comes together with an example. 10 people are playing doubles tennis. How many ways can we select 4 people for the first game? Now, we're not selecting these people in order, we just want 4 people. We'll sort out who's playing who after that, obviously. So, quite simple, we just need 10, choose 4. Now, you can use your calculator with the button on it. You can change it into 10 factorial over 6 factorial times 4 factorial and do it that way. I'm just going to type in 10, shift, divide by to get the little C up there, and then the 4. And 10 choose 4 is 210 different ways. B, how many of these ways include Maria but not Alex? Now, with a restriction like this, we're just trying to think of how many combinations we can come up with that have Maria in them, don't have Alex in them, but they're going to have a mixture of some of the other 8 people. So put Maria in there and then consider that there's 3 spots left to fill. Alex can't fill them, so there's only 8 people to choose from. And that word choose is important. We've got 8 people and we have to choose 3 of them to play with Maria. That will literally be the number of combinations we can make that have Maria in them but don't have Alex. So 8, shift divide to put that C in there, 8, choose 3, that gives me 56 ways that can happen. C, if 4 are women and 6 are men out of our 10 people, how many ways can we choose 2 women and 2 men? All right, we'll just consider them both separately and then consider the combinations. It's almost like that box method, but by now hopefully we don't have to draw up the boxes. So if we've got 4 women and we want to choose 2 of them, it makes sense that we need 4 choose 2. That will give us some combinations of women, but then we need to multiply each one of those combinations by the number of combinations of men that we could make. And if we've got 6 men and we need to choose 2 of them, then we'll have this. So we can find this out with our calculator. We've got 4 choose 2, which is 6, and then we need to multiply that by 6 choose 2, which is 15, and that gives us 90. D, how many ways can 4 players be chosen where the women outnumber the men? All right, well, let's think about that. For the women to outnumber the men, we need either 3 women or 4 women. So here we're naturally deciding to use cases. Consider the case where there's 3 women and 1 man. How many ways can that happen? Well, there's 4 women. How many ways can we choose 3 of them? Choosing 3 is basically the same as choosing 1 to be left out, isn't it? So that's going to be 4. I don't even need to put that into my calculator. And we need to multiply that by the number of ways we can choose that 1 man that plays with the 3 women. If there's 6 men there and we're choosing 1, that'll obviously be 4 times 6. You can put it into your calculator, but that's going to give us 24. Now, I'm going to put that in brackets, not because I need to before I add something. I know that order of operations says to multiply before I add, but to my mind, I'm just keeping that separate as one case, and then I'm going to consider the next case. And to me, the brackets help. It's a little bit like having the boxes, but without having to draw it up. So the other case would be if all 4 are women. Now, there's only 4 women there. So there's only one way that I can choose 4 women out of 4 women. I can say, hey, women, I'm choosing all of you. So this is just going to add 1. So if I've got 4 times 6, that's 24, plus 1, that's going to give me a total of 25 ways that the women can outnumber the men with this group.